Hello everyone. Today we are going to solve these two questions over here. They are from my book. It's written in Portuguese, so if anyone wants the name, it's called in Portuguese Fundamentos de Matemática Elementar. So volume 8, okay? It's volume 8. And these are the numbers of the question. This drawing over here, I got it from the solution, so I took the solution drawing so that we can go faster. So it is, one second. So it is very similar to the question from Math B of 2007, question 2, okay? They are really similar, okay? Especially the 246. I'm going to let them in the same playlist. So let's read the question. So 246, okay? The question 246. He is asking you to find the radius of the base of the cone and the height of the base of the cone that gives you the maximum area of the side this is the side. Look, when I say the side, if you had this cone over here, you have an area, right? A superficial area, but without counting the area of the circle, just the area of this side over here, of the cone, okay? So having this maximum area that is inscribed in a sphere of radius r. So basically over here, this, we are looking to our situation in the front, okay? So this is our cone, okay? This is our cone like this, and the circle is a sphere, okay? This circle over here is the sphere. So this is the situation. Now, what is the formula for the area of this part over here? The area of this part over here, right? Because this will be the first step that we need to use. Now look, let's say we have a cone over here, okay? So this is, I'm going to call this side over here G, okay? This side over here, the radius of the base is R, and this is like this, right? So this is R, right? So what is the value of this circumference? Well, it is 2πr, right? If you have the circumference is 2p of the radius, right? So this is the value of the circumference. Why are we doing this? Well, so that we can open the cone now. Look, this is our cone open. If you join these 2 points together, you will have your cone, right? So how much the value of this arc over here? Well, this arc over here is 2πr. Why? Because when you shut it together, it is going to make this circle over here, right? So this arc over here is 2πr. And what about this part over here? It is G, okay? So look, the value of the area that we want is this area over here. If we had a full circle, big circle, with a radius G, how much would the area of this big circle be? Well, the big circle would be b pi multiplied by the radius squared, but the radius is G, right? G squared, okay? And what would be our circumference? Our circumference would be 2p multiplied by the radius, which is G, okay? And in this case over here, we want this an area that we don't know, but we know that the circumference is 2pr, and here we have a relation. Okay, so this area we want to find is x. So p cuts with p, g cuts with g, this 2 cuts with this g, with this 2, so x will be r, this r over here, p, this p over here, g, the famous RPG, right? So I was just deducing the formula of the area of the side of the cone. Okay, so look, now we want what? In the question he's asking us the maximum area possible, and it is inscribed in this sphere with the radius r, right? So the sphere has that we proved this formula. If you didn't understand very good this how I deduce this formula, look it up. Okay, there are many videos on the internet showing this, as there will be videos showing the next thing I'm going to do, which I'm not going to deduce, okay, because it will take a bit of time. I wish you would try to deduce. So what am I trying to say? Look, in this part now, okay, so we are going to trace a line over here, okay, from E to B. So this will be 90 degrees, and this is the triangle that you find over here. Okay, now why is this important? Because in this formula, what are we trying to find? What is our goal that we need to think? We want to find the maximum area of this side. How can we find this? Well, by deriving. And what will happen when we derive this? And how can we derive this? Well, there are two things that vary, two variables, right? So this will be complicated for us to solve. So what we need to do now is change this to another variable, and remember that r is not a variable. Okay, big R is not a variable. The small one is. The small one changes, but the big one is the radius of the sphere, so it doesn't change. Now look, by tracing this triangle over here, we have this, by tracing this side over here, we have this triangle in the right side. Now let's talk about this side over here. Well, look, this part over here is h, and all of it is 2r. So what do we have left over here? 2r minus h, right? So it's simple, right? So look, this is h, so this is 2r minus h. Sum this with this, 2r minus h plus h, you'll have left 2r. Okay, so all good. Now look, the formulas that I'm going to use now are called metric relations in the right triangle. Okay, so these formulas that I'm going to use, you can find them by searching in Google metrical relations in the right triangle. They are very important. In the future I will make a video deducing them. You can try to deduce them by yourself. Can you see over here? Look, you have three triangles in this over here. The big one, this triangle over here, you have this triangle over here, and you have this triangle over here. By doing similarity of triangles with these three triangles, you can deduce these formulas. Okay, but I won't do them now so that I don't take much longer. So look, the first formula, it tells you that r squared is equal to, so look, this is r squared, this one over here is equal to this multiplied by this. Okay, so two r minus h multiplied by h. Okay, The second formula tells you that G multiplied by its shadow is H. It tells you G squared is equal to its shadow H multiplied by the whole thing to R. Okay, so G squared is equal to its shadow H multiplied by the whole thing to R. Again, these are metric relations in the right triangle. Okay, if you need to look them up. Now R is equal to the square root of H multiplied by 2R minus H, and G is equal to the square root of 2RH. Okay, so now in our formula is R multiplied by G, so our area is equal to pi multiplied by G multiplied by small r, right? So H multiplied by 2R minus H. So why did we do this? Look, this is the same thing, okay? I just put the value of R and G, okay? So why did we do this? Because now we have only H as a variable, okay? The big R is not a variable, as I said, okay? So the area of the side is equal to pi multiplied by, now as it is multiplying we can join them, 2RH multiplied by, now we'll have 2RH, this is minus, right? Minus, okay, so minus H squared. Okay, so the area of the side is equal to pi square root of 4R squared H squared minus 2R H cubed. I just multiplied this over here, okay? Now look, what are we going to do now? Well, now we have only one variable, so now we can derive it to find the maximum area that he wants, okay? The maximum area, the maximum area of the side, okay? So the derivative of A of L is going to be pi. Now let's just talk a bit about this derivative. Look, if I say that A is equal to U squared, okay, so the derivative of A will be 2 multiplied by U multiplied by U comma, right? So this is what we are going to do, okay? We are going to call U is equal to all this over here, okay? So this is U. This is U. Okay? Now, what is U comma? Now, U comma is going to be, this is 4 over here, okay? So it's going to be this derivative minus this derivative, right? So what is the derivative of this part over here? Well, let's call V is equal to 2R squared H squared, okay? 4R squared H squared. So the derivative of V is equal to, how is equal to what? Now we have 2 multiplied by 4 is going to be 8R squared H, and then wait, yeah, this is it, yeah, 8R squared H. So I could have done it immediately. So over here, so the derivative of this part over here, so 8 r squared h minus two here it is, wait, this is cubed over here. Okay, so this is cubed, so because here it's cubed, so 2 multiplied by 6 is r h squared. Okay, so this is going to be ucom. So let's derive now. Okay, so AL line is equal to pi. Now remember, we had AL was equal to pi square root of u. Okay, this is u. Okay, so AL comma is equal to pi multiplied by 1/2 multiplied by u to the minus 1/2. Why? Because it was 1/2 minus 1. Okay, so it is equal to minus 1/2. Minus 1/2. Okay, multiplied by u comma. Okay, so now we just need to put the values of u's. Okay, so pi divided by 2 multiplied by, now you see that this is minus, so the square root of u. What is the square root of u? Well, this is the square root of u. Over here, multiplied by u comma. What was u comma? It was over here. Over here. So this is u comma. Now what do we do with this? We say that it is equal to 0, right? We say that AL comma is equal to 0. So we will have that all this is equal to 0. So everything multiplying is going to the other side with multiplying the 0, so it will be 0. So we have 8r squared h minus 6r h squared. This part over here is equal 0. So 8r squared h is equal to 6r h squared. And so r cuts with r, and then you can say, because the h must be different than 0, so it will cut. So h is equal to 8 multiplying r dividing by 6, right? There is this r over here yet, we just cut the square. Okay, so h is equal to dividing by 2, 4r divided by 3. Okay, so this is our answer for h. Now let's see what he wanted. He wanted us to say the value of the radius of the base and the height in terms of r for the maximum. So we already found the, so over here we had a relation with r's and h, right? So let's use it now. Okay, so over here, now what is the value of r? Let's put h. So r is going to be the square root of 2rh minus h squared, right? So, and h is 4r divided by 3, so r is equal to the square root of 2r. H is 4r divided by 3 multiplied by 4r divided by 3 minus 4 4r divided by 3 squared. So r is equal to 8r squared divided by 3 minus 16r squared divided by 9 to the square root. So r is equal to and 24 r squared divided by 9. This I just multiplied 3 above and 3 down, okay, minus 16 r squared divided by 9. Okay, so we will have that r is equal to 8. 25 minus 16 is 8 r squared divided by 9 to the square root. So r is equal to, now 8, remember that 8 is 4 multiplied by 2, so it will be 2 divided by 3, r square root of 2. Okay, so this is what he asked us, right, Maxim? Okay, to find the radius and the height, so this is the answer. Okay.